Hi, today I will continue with the next topic, which is 1.2 Mathematical Logic. What is mathematical logic? Mathematical logic is a way of reasoning. This method provides the rules and the techniques to determine whether an argument is valid. The valid argument or a statement that can be shown to be true under certain conditions can be called theorem. So for example, if x is an even integer, then x plus 1 is an odd integer. And this statement is true under the condition that x is an integer is true. Proposition. Proposition or a statement is a sentence that is either true or false, but not both. So we use lowercase letters to denote the propositions. For example, p:2 is an even number. This is the example for true proposition. q:3 is an odd number. This is also true proposition. r:(a) is a consonant. So this is the example for a false proposition. So the following are not proposition, such as my cat is cute. This is not a proposition. Are you in charge? This is also not a proposition. Proposition is a declarative statement. It must not a command or a question or exclamation. Negation. Negation of P or tilde P is the statement obtained by negating the statement P itself. So we use the symbol tilde, which can be read as not P. Truth values of P and not P are opposite. So this is the truth table for negation. So for P, if true, then not P is false. If P is false, then not P is true. So this is the example how the negation can be applied in statement. If P:, state that A is a consonant, then the negation P will state A is not a consonant. Conjunction. Conjunction can be explained as follows. Let P and Q be statements. So the conjunction of P and Q can be obtained by joining the statements P and Q using the word AND, which is this symbol. And by using the truth table, if P is true, Q is true, then P and Q is true. If P is true, Q is false, then P and Q must be false. Similarly, when P is false, Q is true, then P and Q must be false. And lastly, if P is false, Q is false, then P and Q must be false. So it can be summarized like this. If both are true, then the P and Q is true. The rest give false. Disjunction. Disjunction has the symbol of P or Q. Let P and Q be statements. The disjunction of P and Q is the statement formed by joining the statements P and Q using the word OR. This is the truth table for disjunction. If P is true, Q is true, then P or Q is true. Similarly, if P is true, Q is false, P or Q is true. If P is false, Q is true, then P or Q is true. But when the P is false, Q is false, then P or Q is false. So it can be explained like this. If either one of the statements give true statement, then the result is true. Otherwise, everything is false. Implication. Implication can be explained as follows. Let P and Q be statements. The statement for implication is if P then Q. Implication also can be known as the conditional statement. This is the symbol if P then Q. So there are many ways to read the symbol, such as if P then Q, P is sufficient for Q, Q if P, Q whenever P, and P implies Q. The truth table for implication will be like this. So we use P as the hypothesis and Q as the conclusion for this type of implication. So if P is true, Q is true, then if P then Q is true. However, if P is true, Q is false, if P then Q is false. And then if P is false, Q is true, then if P then Q is true. And lastly, if P is false, Q is false, if P then Q then true. So meaning that for this one, we just focus on the last, which is the Q, the conclusion. So the result will follow the conclusion, except that if P is false, then Q is false. This is the true implication. There are three types of implications, such as converse, inverse, and contrapositive. Let us see one by one. To begin, let the statement P is today is Sunday, and then the statement Q, I will wash the car. The implication for these two statements is, if today is Sunday, then I will wash the car. So to make a converse statement using this implication is, if I wash the car, then today is Sunday. So this converse can be written as if Q, then P. For inverse of the implication, we use not P, then not Q. So for the statement will become, if today is not Sunday, then I will not wash the car. And then lastly, for the contrapositive, the notation is, if not Q, then not P. So the statement for the implication becomes, if I do not wash the car, then today is not Sunday. So make sure you know the difference between three types of implication statement. By implication, let P and Q be statements. The statement of P implication is P if and only if Q. The notation is this one. The P if and only if Q can also be read as follows. P is necessary and sufficient for Q, Q if and only if P, and Q when and only when P. So this is the truth table for the by implication. If P is true, Q is true, then the P if and only if Q becomes true. If P is true, Q is false, then the result is false. Similarly, when the P is false, Q is true, the result is false. But for P is false, Q is false, the P if and only if Q is true. Meaning that for this by implication, if both statements give the same truth value, then the result is true. Otherwise, it's false. Precedence of logical connective. So this is the order of priority of each symbol. So the negation is the highest, meaning that to understand the more complex mathematical logic sentence, make sure you prioritize the negation first, and then followed by the conjunction and disjunction. And then the next one is if then, and the last one is if and only if. I will show you the example on how to utilize this precedence of logical connective later.